Hey everybody, Trey here, and welcome to my 2026 tornado season forecast. This is my fourth annual spring forecast, and I know many of you are itching to get a glimpse at what this season might have in store tornado-wise here in the US. As we always do, we're going to use our collection of modulating factors and analog years to come up with a forecast for tornado frequency and distribution for the March through June timeframe, the climatologically favored period for increased tornado activity here in the U.S. We're not looking at severe weather as a whole, so we're excluding hail, wind, etc. We're forecasting relative to average tornado frequency, so how many tornadoes are going to occur, and distribution, where those tornadoes are going to occur. And we're going to confine our analysis domain to areas that typically see tornado activity on a somewhat regular basis, essentially the plains, the Midwest, the Mid-South, and the Southeast. We're not going to look at some of the more unusual locations for tornadoes like the Pacific Northwest, the Northeast, etc. As always, I'll put links to any websites or journal articles I mentioned in this video in the description box below so you can do some research on your own. Also, keep in mind that this is not an exact science. Tornadoes are hard to predict just a few hours ahead of time, let alone months in advance like we're doing here, and as we've discussed frequently, tornadoes are often influenced by very small-scale features that simply can't be forecast this far in advance. But we can at least make a highly educated guess regarding what might happen this season based on the factors we'll discuss, which have been shown in peer-reviewed research to impact tornado frequency and distribution in the U.S. on some level. So without further ado, let's go ahead and get started. First, let's see where we stand so far in 2026. It's been a fairly quiet start to the year, but as of the recording of this video, we sit right around average for this point in the year. This was mostly thanks to a robust QLCS tornado event in the Southeast on February 14th, which comprises about half of our total tornado reports for 2026. A handful of other tornadoes have occurred across the Southeast this year, along with a few in Oklahoma in January and in the Midwest on February 19th. Alright, let's dive into the factors that tend to modulate tornado frequency and distribution in the U.S. during the spring. If you've watched my spring forecasts before, you know that I like to look at three main factors: global climate teleconnections, sea surface temperature anomalies in the Gulf, and the degree of drought in the elevated mixed layer source region. Let's start off with global climate teleconnections, and we're going to focus on one in particular called the El Niño Southern Oscillation, or ENSO. ENSO involves sea surface temperature anomalies in the equatorial Pacific, basically the departure from average of the sea surface temperatures in the portion of the Pacific Ocean that lies along the equator. As you may know, ENSO has different phases. In basic terms, if the sea surface temperatures in the equatorial Pacific are warmer than normal, as in the top panel, we are in an El Niño phase, whereas if the sea surface temperatures in the equatorial Pacific are cooler than normal, as you see on the bottom panel, we are in a La Niña phase. And if the sea surface temperatures in the equatorial Pacific are about average, we are in a neutral phase. Now, there's recently been a change in the official index that's used to monitor ENSO phase. If you've watched my past spring forecasts, we've used a variable called the Oceanic Niño Index, or ONI, which is the 3-month running average of sea surface temperature anomalies in the Niño 3.4 region, which is the portion of the equatorial Pacific between 5 degrees north and south latitude and 120 and 170 degrees west longitude. This has been the standard variable used to monitor ENSO for years now. But as global sea surface temperatures continue to warm overall, it's becoming harder and harder to tell what's normal and in turn what's above normal and below normal. So we need to account for the overall warming trend in the global tropics when analyzing the anomalies in the Niño 3.4 region. If we didn't, warm anomalies and El Niño would become much more common, while cool anomalies and La Niña would become much less common. That's where our new official metric comes in, the Relative Oceanic Niño Index, or RONI. RONI is calculated the exact same way as the old ONI was, the 3-month running average of sea surface temperature anomalies in the Niño 3.4 region, only with RONI, the average sea surface temperature anomaly of the global tropics is subtracted out, and then the values are rescaled to match the amplitude of the old ONI. Generally, RONI is not going to be that much different than ONI. Here's a graph comparing the old ONI, which is the red curve, to the new RONI, which is the blue curve. And you can see that there's not much difference between the two in most cases, and we still see the same oscillations of ENSO that we saw with ONI. RONI just makes what we're looking at in terms of ENSO a little clearer because it's less sensitive to the base climatology period, i.e. what is considered normal. It also better reflects shifts in ENSO-related cloud and rainfall patterns in the Pacific, which are tied to shifts in the jet stream and the overall weather downstream here in the U.S. Again, the RONI uses a 3-month running average, which means that instead of measuring the sea surface temperature anomaly in each individual month, the RONI averages the sea surface temperature anomaly over each consecutive 3-month period. For example, January, February, March, then February, March, April, then March, April, May, and so on. This helps smooth out random fluctuations that might occur in the data. Now, RONI is calculated slightly differently than ONI, but the criteria for what constitutes each ENSO phase is exactly the same as with ONI. If RONI is greater than positive 0.5 degrees Celsius for a single 3-month period, we would be in a warm phase. If the RONI is less than, i.e. more negative than negative 0.5 degrees Celsius for a single 3-month period, we would be in a cool phase. And if the RONI is between negative 0.5 and positive 0.5 degrees Celsius, we would be in a neutral phase. If we're in a warm phase for more than 5 consecutive 3-month periods, we would be in an El Niño. If we're in a cool phase for more than 5 consecutive 3-month periods, we would be in a La Niña. And the same thing applies for the neutral phase. Again, ENSO is a cyclic phenomenon, hence the name El Niño Southern Oscillation. We oscillate back and forth between El Niño, neutral, and La Niña phases. Let's take a look at how ENSO has evolved over the past year. On this map, yellows, oranges, and reds indicate warmer than normal waters, while greens, blues, and purples indicate cooler than normal waters. The date is at the bottom left. To start 2025, we were in a weak to moderate La Niña with mostly cool anomalies dominating our Niño 3.4 region. Waters warmed throughout the spring, causing La Niña to fade into more of a neutral state before cooler than normal waters returned and induced a resurgence of La Niña to close out the year. But as we headed into 2026, the waters in the Niño 3.4 region have warmed some, with La Niña conditions still holding on but more of a mixed bag of anomalies across the area at present. This signals that a transition to neutral and eventually El Niño conditions is underway. This is supported by our climate models, as you can see on this graph. Each successive month through July 2026 is on the horizontal axis, while the average sea surface temperature anomaly in the Niño 3.4 region is on the vertical axis. Pretty much all of our major models show steadily warming waters throughout the spring and into the summer, with neutral ENSO conditions expected to take hold as we head into March and continue through at least the first half of spring until a weak to moderate El Niño emerges at some point from the back half of spring into the summer. Latest model runs also suggest that the background pattern may start showing the hallmarks of El Niño by May. Here is a map of the European model forecast for essentially rising and sinking air across the globe over the next several months. Rising air is denoted by the blues and greens, sinking air by the browns. Notice how rising air really starts to overspread the entire Pacific Ocean and North America by May and June. This is evidence that the ocean and atmosphere may couple together. In other words, the warming waters in the equatorial Pacific may start impacting what's happening in the atmosphere as early as May. Now, this may be on the earlier side, but this is expected to happen at some point from late spring into summer. And finally, here are our probabilities for each ENSO phase as we head further into 2026 from the Climate Prediction Center. Once again, time is on the horizontal axis in the form of our 3-month periods, and the percentage chance of occurrence of each ENSO phase is on the vertical axis. The orange bars represent El Niño, the blue bars represent La Niña, and the gray bars represent the neutral phase. This latest forecast suggests that neutral ENSO has the greatest odds of occurring through the spring, and that El Niño may not be favored until summer. Regardless, we see increasing odds of El Niño taking shape from early spring onward, further evidence of our expected transition from La Niña. So how does all of this impact the atmosphere? ENSO tends to modulate the position and amplitude of the jet stream, especially over North America, as you can see on these conceptual models of the atmospheric impact of El Niño on the top and La Niña on the bottom. Now, these graphics show the impacts during winter, but the same ideas regarding the jet stream generally hold for spring. In an El Niño phase, the jet stream tends to be a bit more muted and shifted farther south. You can imagine what impact this might have on springtime severe weather. A more muted, less intense jet stream during El Niño means a less intense low-level response, and therefore a slightly less favorable pattern overall for widespread severe weather, including tornadoes. On the other hand, during La Niña, the jet stream is far more amplified with a lot more robust troughs impacting the U.S., which means severe weather, including tornadoes, tends to be more frequent and widespread, even though in the winter those troughs can get shunted off to the east, drying out the southern U.S., and the neutral phase is somewhere in the middle. These ideas have been supported by ample peer-reviewed research, including this paper by Cook et al. 2017, who tried to find a linkage between ENSO phase and U.S. tornado outbreaks in the winter and early spring, basically January through April. Let's take a look at their figure 3C and D, which show normalized tornado counts for both March and April in the U.S. Basically, they split up the area east of the Rockies into a grid, tallied up all the tornadoes in each grid box during each month for each ENSO phase, then divided those counts by the number of months that each ENSO phase occurred during the study period, which was 1950 to 2010. For example, let's say a certain grid box had 10 total tornadoes during all El Niño marches in the study, and that there were 20 marches where El Niño was present during the study. You'd divide 10 by 20 to get a normalized tornado count of 0.5 for that grid box for El Niño marches. For each of these figures, El Niño is on the top left, La Niña is on the top right, and neutral is on the bottom left, and the warmer the color of the contour, the higher the normalized tornado frequency within that contour. For March, neutral periods tend to favor slightly enhanced normalized tornado counts from the southern plains into the mid-south, while neutral Aprils tend to favor enhanced activity across both the central and southern plains and the Midwest. Now, as we know, ENSO is not a static phenomenon, which can be a drawback to using the individual ENSO phase during each month. Instead, research by Lee et al. 2016 suggests that looking at how ENSO phase evolves in the months leading up to and throughout the spring may do a better job at helping us predict tornado frequency and distribution in the U.S. They looked at several different ENSO progressions and how tornado outbreak frequency and distribution changed among them. This spring's expected ENSO progression most closely follows what Lee et al. 2016 called the transitioning La Niña, in which a multi-year La Niña transitions into an El Niño by late spring of the year in question. Here are their findings taken from the supplementary data accompanying their 2016 paper. Conceptual month-by-month sea surface temperature anomalies for a transitioning La Niña are on the left, and on the right are gridded probabilities of tornado outbreaks for each month from February to May in a transitioning La Niña period. The shaded regions represent areas with an elevated probability of seeing a tornado outbreak, with darker colors representing higher probabilities. Grid boxes with black dots indicate that those probabilities are statistically significant. In March, a robust signal for increased tornado outbreak frequency exists from the Ozarks into the Mid-South and Midwest, with a bit of a secondary maximum in the southeast. The focus shifts to the central and southern plains, particularly Kansas, Oklahoma, and North Texas in April, with a region of enhanced probabilities from the Midwest into the Mid-South as well. Signals don't quite emerge as clearly in May, but we do see a couple of potential areas to watch, including the central plains near the Kansas-Nebraska border and parts of Texas. Now, June is a bit more up in the air as the linkage between ENSO and tornado activity in the U.S. weakens the farther you go into the season. We'll have to rely a lot on our analog years to give us an idea of what June might look like. More on that later. Overall, it seems like we could see a Midwest to Mid-South lean-to tornado activity early in the season before shifting to more traditional tornado areas across the plains in April and May. Another facet of ENSO that could impact tornadic activity in the U.S. this spring is an El Niño Costero event that is expected to develop and strengthen over the next few months. El Niño Costero describes a prolonged period of warmer-than-normal waters off the coast of Peru in South America. It's a fairly localized event and can lead to increased thunderstorm activity in northwest South America, but it can also have impacts on severe weather in the U.S., particularly because it tends to strengthen and amplify the subtropical jet. Here in the U.S., our weather is influenced by the polar jet, which is situated farther north, and the subtropical jet, which is situated farther south. The outflow aloft from the increased thunderstorm activity over South America induced by El Niño Costero can actually lead to an amplification of the subtropical jet. This leads to more storm systems traversing the southern U.S. within the subtropical jet stream, in turn yielding more opportunities for severe weather, including tornadoes. El Niño Costero also tends to weaken the high-pressure ridge that often sets up over the east coast, which also favors more frequent storm systems across the southern tier of the U.S. Significant warming has already begun in the waters off the Peruvian coast to start 2026, and models indicate that this should continue in earnest throughout the spring and summer, perhaps morphing into a strong El Niño Costero event. As you may know, there are a bunch of other teleconnections that impact weather across the globe: the NAO, the PDO, the AO, etc. The problem with many of these other teleconnections is that they fluctuate on much smaller timescales than ENSO, which makes using them as a variable to forecast tornadic activity months ahead of time, like we're doing in this video, almost impossible. ENSO changes quite predictably, allowing us to get a good picture of how it will evolve many months into the future. Also, based on research, ENSO appears to have the strongest influence on U.S. tornado activity of any of the major climate teleconnections. This makes it quite useful for our purposes here, and it's why I focus on it in my spring forecast as opposed to other teleconnections. Now, there's one other feature in the Pacific to monitor, and that is this blob of warmer water in the North Pacific. It's not necessarily a full-on teleconnection by itself, although it does contribute to the Pacific Decadal and North Pacific oscillations, and there's not really any peer-reviewed research providing evidence of a linkage to spring tornado activity in the U.S., but many reputable folks have hypothesized that these widespread warmer-than-normal waters in the North Pacific can enhance tornado frequency in the U.S. For example, this warm blob has been in place for quite some time now, including 2023, 24, and 25, all of which featured above-average spring tornado counts here in the U.S. Model forecasts also suggest that it will remain in place for the foreseeable future. So while this warm blob will not be a foundational piece of my forecast, it's definitely something to keep in mind going forward. Alright, let's move on to sea surface temperature anomalies in the Gulf. As you know, the Gulf is the source of our moisture for severe weather events in the U.S. As low-level flow turns out of the south ahead of developing surface lows, that warm, moist, unstable air mass over the Gulf gets transported northward into the U.S. to set the stage for severe weather. We also know that warmer air holds more moisture. Intuitively, if the sea surface temperatures in the Gulf are warmer than normal, the air mass atop the Gulf that gets advected into the U.S. is warmer and can hold more moisture, and thus is more unstable, and the potential for severe weather, including tornadoes, increases. On the other hand, if the sea surface temperatures in the Gulf are cooler than normal, the air mass that gets advected northward is less unstable, and therefore the potential for severe weather, including tornadoes, decreases. This is supported by Molina et al. 2016. In their Figure 3, they illustrate the difference in instability anomalies between cooler than normal Gulf waters on the left and warmer than normal Gulf waters on the right. Mixed layer CAPE, which is our main measure of instability, tends to be near or below normal when the waters in the Gulf are relatively cool overall, as shown by the blue colors, and above average mixed layer CAPE is much more widespread when the waters in the Gulf are relatively warm overall, as shown in red. Currently, widespread warmer than normal waters comprise nearly the entire Gulf, including several areas of significantly above average sea surface temperatures. Waters off the west coast of Florida had been quite a bit cooler than normal given the significant cold air intrusions into the southern U.S. and Gulf to start the year, but even those waters have started to warm notably in recent days. Models suggest that Gulf waters should remain warmer than normal for the next several months, which may mean more robust instability than is typical seeping inland this spring. Finally, let's take a look at drought in the elevated mixed layer source region. If you followed the channel for any length of time, you probably know what the elevated mixed layer, or EML, is. The EML is that layer of warm, dry, well-mixed air that emanates from the higher terrain out west, western Mexico, West Texas, New Mexico, and areas northward, and gets transported atop the low-level moist layer out east amid the westerly or southwesterly mid-level flow. This helps to thwart thunderstorm development for much of the day until the cap erodes and allows instability to build effectively. However, if the EML is too strong, in other words, if that warm layer is a bit too warm, That can make full cap erosion difficult and can thwart thunderstorm development altogether in a given setup. Persistent, intense drought in the EML source region means hot and dry conditions in that higher terrain out west, which can get transported out east and cause chronic capping issues for severe weather events in the plains and Midwest, limiting overall tornado potential. Therefore, we don't want to see too much drought across the EML source region, as that will keep the EML in check, if you will. Here's our current map of drought across the U.S. from the University of Nebraska at Lincoln's Drought Monitor. The darker the shade of red, the more extreme the drought is. And despite the fairly dry stretch many of us have endured this winter, we're actually not doing too bad. The bulk of our EML source region is experiencing some kind of drought, but most of it is light to moderate, with a few more severe patches embedded within, especially across the southern Rockies. Compare this to last year at this time, and things look relatively similar, with a decent amount of drought across portions of the EML source region. If we were seeing something like this right now, which were the drought conditions leading into spring 2021, a below-average tornado season, I would be more concerned. The problem is that things are not expected to get any better over the coming months. The snowpack across the Rockies is running well below average for this time of year, and little change is expected going forward. The Climate Prediction Center's seasonal drought outlook from now through the end of May also shows drought persisting across much of the southern plains and Intermountain West, as you see in brown, and an increased likelihood of drought developing and worsening from the desert southwest into the central and southern high plains, as you see in yellow. If this occurs, we may start to see some issues with a stronger EML later into the season, especially as El Niño starts to take hold. Highly amplified troughs tend to provide plenty of lift to overcome a strong EML, but as we saw earlier, the jet stream tends to be a bit less amplified during El Niño events. So for now, I'm not overly concerned with our drought situation, but it does give me some pause, particularly for the back half of the season. Alright, now for the fun part. Let's dive into some analog years. That way we can see what happened tornado-wise in years that had similar background conditions. I went through the database going back to 1950 with the goal of selecting years that had similar ENSO progressions, Gulf sea surface temperature anomalies, and drought out west. That means years that generally followed Lee et al. 2016's transitioning La Niña progression, featured above average sea surface temperatures in the Gulf, and had what I'm calling widespread moderate drought in the EML source region, perhaps worsening with time. I also considered a warm blob in the North Pacific to be a positive factor in these analog years. ENSO progression was given the most weight in my analysis, as it seems to have the strongest correlation to U.S. tornado activity of any of our modulating factors. So if a potential analog year was a good match for ENSO progression, but not such a good match for Gulf sea surface temperatures and or EML source region drought, I still considered it a good analog, although years that showed good similarities to all three variables were considered the best. Now remember, this is a subjective exercise. I didn't use some algorithm to pick out these analogs, so there may be some years that I threw out that you might put into your analysis, or vice versa. Just a couple caveats. First, the database of sea surface temperature anomalies only goes back to 1982, so we'll have to disregard Gulf sea surface temperature anomalies and the North Pacific warm blob for any years prior to that. Also, the archive of drought monitor maps only goes back to 2000, so to analyze drought for analog years, we're going to use something called the Palmer Drought Severity Index, which is a measure of how prolonged dryness or wetness is in a region, rather than a more short-term look at drought as exhibited in the drought monitor maps. The archive of Palmer Drought Severity Index maps goes back to 1950, which is useful for our purposes. Here is our current Palmer Drought Severity Index map. Yellows, oranges, and browns represent long-term dryness and, in turn, drought, while greens represent abnormal long-term wetness. Some of the areas highlighted on our current drought monitor map also appear on our Palmer Index map, particularly the central and southern Rockies, meaning that drought conditions across these areas have been festering for a prolonged period. But elsewhere across the EML source region, we don't see a ton of intense, prolonged drought, which also lessens my concern a bit, at least for the front half of the season. In my research, I identified 12 different analog years whose background pattern had varying degrees of similarity to that expected for this year. In the interest of time, I'm only going to discuss my top 5 analogs here, but all of these factored into my forecast. My first analog is 2023. 2023's ENSO progression follows this year's very closely. Coming off a resurgent La Niña in 2022, the weak La Niña that was in place to start 2023 quickly faded by early spring, leading to a transition to neutral and eventually El Niño by the end of spring into early summer. Sea surface temperatures in the Gulf generally remained above average to well above average throughout the spring, and our North Pacific warm blob was in place as well. Drought was not a perfect match, but we did have widespread weak to moderate drought in at least eastern portions of our EML source region. 2023 came in slightly above average tornado-wise across the U.S., with 850 tornadoes in total from March through June, compared to the climatological average of about 750 to 800. However, this may be a bit deceiving because of what happened early in the season. March came in well above average, but that was mostly due to the high-end outbreak that occurred on March 31st. This event featured over 140 tornadoes in a 24-hour period from the Midwest to the Southeast, ranking it third all-time behind only the 2011 and 1974 super outbreaks. If we take out this event, March actually came in fairly close to average, with activity skewed toward the Southeast. April's count was slightly below average, with small amounts of tornadic activity scattered throughout the month, with no real hotspots emerging. May was even quieter, coming in well below average. Over half of May's total came from a multi-day outbreak sequence just before mid-month across the central and southern plains. Otherwise, most of the activity was confined to the high plains. June, however, was quite a bit above average, with a good chunk of the activity from Wyoming down to Texas. Next up is 2009, which fit the transitioning La Niña pattern quite well, albeit with perhaps a slightly later dip into El Niño than what's expected in 2026. Gulf sea surface temperatures were about average for much of the season, with some periods of slightly cooler than normal waters overall, and some periods of slightly warmer than normal waters overall. Our warm blob in the North Pacific was present throughout much of the season as well. Drought remained fairly limited out west. Spring 2009 was another above-average season for tornadoes overall, with nearly 900 tornadoes in total. March came in above average with a similar skew toward the Midwest and Southeast as we saw in 2023, alongside a bit of activity in the plains. April ended up just a hair above average, with activity concentrated across the Southeast and perhaps from Kansas to West Texas. Once again, however, May was less active than normal, tallying a slightly below-average tornado count. Activity saw a notable shift toward the Mid-South and Southeast, while the plains were mostly quiet. In contrast, June was active to hyperactive, with a clear hotspot from Wyoming and Colorado into Nebraska and Kansas. The Dakotas and Texas were also somewhat active as well. Our next analog is 2018. 2018 was a transitioning La Niña year, although La Niña held on a little longer into the spring than is expected this year, and the dip into El Niño happened in the fall, a bit later than expected as well. Still, it's a good match, and especially so because of how well it matches with the other modulating factors. Gulf sea surface temperatures remained above average for the vast majority of the spring, and drought was moderate and widespread, especially across central and southern portions of the EML source region, and it worsened as the spring progressed. Interestingly, 2018 also featured a very similarly depleted Rockies snowpack as we currently have heading into spring 2026. Now, I know you storm chasers out there cringed when I said 2018. That's because it was one of the more dismal tornado seasons in recent memory. The season began slowly in March, with below-average activity almost solely confined to the southeast. April remained a bit quieter than normal. The plains were absolutely dead, while the vast majority of the activity was concentrated from the Mid-South into the southeast. The quiet season continued in May, although activity that did occur was focused across Kansas and Oklahoma, with a lobe extending into Colorado and Wyoming. June was near average, with mostly scattered activity across the central and northern plains into the Midwest. 2002 is next, and while the ENSO progression is a good match, we weren't in a full-on La Niña to start the year as we were in our first few analogs. However, neutral conditions dominated the spring before a transition to El Niño later in the season, so it's still a fairly good match. And, like 2018, the other modulating factors matched well with what's expected in 2026. Sea surface temperatures in the Gulf were generally average to slightly above average, aside from some cooling late. and drought was widespread and moderate across much of the EML source region and worsened significantly throughout the season. Spring 2002 also began with a vastly depleted Rockies snowpack. Overall, spring 2002 was another season whose tornado count fell well short of the norm. March came in below average. The tornado count comprised mostly of a couple localized outbreaks across Texas. April ended up much below average as well, with a concentration of activity in the Ohio River vicinity and a smattering of activity in the plains. May's tally was also below average, but like 2018, much of the activity occurred in the plains, this time from Kansas to West Texas. We batted 4 for 4 in below average months in the spring of 2002, as June was also lackluster. No real hotspots emerged, except for maybe a corridor from the northern plains into the Midwest and in the central high plains vicinity. The final analog we're going to discuss is 1976. 1976 was a very good match to the transitioning La Niña progression, with the exception that the prior year's La Niña wasn't technically resurgent. But nonetheless, 1976 started off with a moderate La Niña that transitioned into neutral and eventually El Niño by the end of spring into early summer. As mentioned earlier, we don't have any sea surface temperature data to go off of pre-1982, but drought was fairly minimal across the EML source region. For these older years, don't pay so much attention to the actual tornado count, but rather the distribution of tornadoes. That said, if we were to account for the limitations in tornado reporting back then, 1976's tornado count may actually be closer to average or even slightly above average. March was incredibly active with multiple outbreak days. Heavy concentrations of activity existed across the Midwest as well as across the Ozarks into the southeast. Activity shifted into the plains, particularly parts of Kansas and Oklahoma and much of Texas in April, and May continued the Texas focus. The corridor from North Dakota into the Midwest was the most active in June, with a smattering of activity elsewhere. Other analogs I found were 1951, 2006, 1972, 1997, 2012, 1963, and 1968. The latter few were the weakest matches to our current and expected background pattern, particularly the ENSO progression, but including them did have some utility. Now that we've selected our analogs, let's take a look at the composite upper air pattern in these years. Using the NCEP NCAR reanalysis datasets, I've plotted the composite 500 millibar geopotential height anomalies for all of the 12 analog years we just discussed. I gave extra weight to our best analogs, which is why you see those years listed twice on the bottom. Blues and purples indicate lower than normal heights and, in essence, a tendency for increased troughing and perhaps an elevated frequency of severe weather, while greens, yellows, and oranges indicate higher than normal heights and, in essence, a tendency for increased ridging and perhaps a lowered frequency of severe weather. Let's start with March, and right away you'll notice fairly significantly lower than normal heights across much of the western half of the country. This explains why many of our analog years, including many of those we didn't discuss in detail, tend to have active marches. These below normal height anomalies may be associated with increased troughing across the western U.S., enhancing the frequency of severe weather downstream across the central U.S. In April, we continue to see below normal heights across the western U.S., but the signal is certainly not as strong as it was in March. We also see the development of lower than normal heights across the Northeast. This may be a reason why many of our analog years trended below average tornado-wise across the U.S. in April. Remember that the jet stream follows a wave-like pattern. If you have troughing out west and troughing out east, it's somewhat natural to have ridging fill the void in the middle, which can decrease the frequency of severe weather in the central U.S. Storm chasers, I advise that you cover your eyes and plug your ears as we head to our May composite. Every single one of our analog years had below average to well below average tornado activity in May. Every single one, even adjusting the older analogs for tornado report inflation. And this is why. We see a robust signal for above normal heights across much of the western and central U.S. This means a tendency for more ridging over these areas, which is unfavorable for widespread severe weather. We also see a lean toward below normal heights and perhaps troughing across the eastern U.S., which often acts to further reinforce the upstream ridge and the overall unfavorable pattern. Our composite for June, however, is promising. Below normal heights return across much of the western and central U.S., perhaps indicating increased troughing or just a weakening of the typical ridge that starts to build in across the southern U.S. as we head into summer. Either case would tend to be associated with increased severe weather frequency across the central U.S. Finally, let's take a look at some of our latest model data and official forecasts. Starting with our medium-range models, both the GFS and European model ensembles are hinting at our current western U.S. ridge breaking down and troughing making a return in early March. This could up the chances for early season severe weather across the central and southern U.S. Precipitation forecasts from our long-range models for March through May suggest that the best chances for above-average precipitation exist across the Midwest and Mid-South, while the central and southern high plains may remain on the drier side. Of course, these are just precipitation forecasts and are not directly related to severe weather, but it can give us an idea of where the most unsettled weather may be. These precipitation forecasts are essentially mirrored in the latest 3-month precipitation outlook from the Climate Prediction Center, also valid from March through May. They also suggest that the greatest chances for above-average precipitation exist across the upper Midwest down into the Ohio Valley and Mid-South, while areas from the Central Plains into the southwestern U.S. have the greatest risk of below-normal precipitation, which would exacerbate the drought situation in the EML source region. So, taking all of this information into consideration, what do I think is going to happen this year? Given the signals in our medium-range models and a tendency for our analog years to start out active, I think March will be average to above-average tornado-wise in the U.S. Some areas to watch for heightened activity may be from the southern plains into the Mid-South and Southeast, and perhaps across the Midwest. In contrast, I think things start to slow down in April with a below-average tornado count overall. I wouldn't be surprised if we see a couple notable events in April, but based on our analogs, April tends to be on the quieter side overall. Both Lee et al. 2016 and our analog suggest that any activity that happens could focus from Kansas to Texas, as well as across the Ohio and lower Mississippi Valley vicinities. I have the greatest confidence in my forecast for May. The fact that every single analog year featured a below-average May, likely thanks to a tendency for western U.S. ridging to take hold this time of year, tells me that 2026 is likely to follow suit. Therefore, I'm going with below average to well below average tornado activity across the U.S. in May. Now, that doesn't mean there won't be some good storm chasing to be had, and there are likely to still be a few notable days sprinkled throughout the month, but it might be a stark change from the last couple of Mays, which were quite active. The action may tend to concentrate across the Central Plains, including Nebraska, Kansas, and Colorado, as well as perhaps across Texas. As always, tornado activity in June is difficult to pinpoint because our ENSO teleconnection is weakest at this point in the season, so we'll have to rely more on our analogs. I think June will be average to maybe slightly above average this year, as was the case in several of our analog years. The central to northern high plains, including Wyoming and Colorado, tend to be fruitful in analog Junes, with particularly high-quality tornadoes as well. These higher terrain areas are also less susceptible to capping issues should the EML become chronically strong due to increasing drought later in the season. Also, given a tendency for decreased 500 millibar heights across the western U.S. in analog Junes, activity may linger in the central to southern plains, including Kansas, Oklahoma, and Texas. Putting all of this together, an active March followed by a relatively quiet April and May, capped by an active June, I think we're in store for a slightly below-average tornado season overall. Activity will likely be shunted east early before shifting back to more traditional tornado hotspots like the central and southern plains for peak season, albeit in a more sporadic nature in terms of frequency, and the central to northern high plains late. So that's going to wrap things up for this year's tornado season forecast. Let me know what you think in the comments below. As always, we'll revisit this forecast in a video after the season is over to assess how our forecast performed, so stay tuned for that. Again, this is just an educated guess, and the season could turn out much differently than expected due to factors that are unable to be forecast at this range. Plus, one major outbreak can skew the numbers toward above average, even though the remainder of that month may be quiet. And just because I'm calling for a below average year tornado-wise does not mean it will be a lackluster chase season overall. There will surely be plenty of beautiful storms and tornadoes to chase. You just might have to work a little harder to find them. With that, thanks for watching, and we'll see you in the next video.
We have a very active weather pattern on the way to start the month of March, and it's all going to begin with a winter storm risk for the first few days of the month. And we need to give you all the details on that. And that's what we'll do for the first portion of the video. After that, we'll get past that time frame and speak on what's next. And I think we're going to get an extremely active pattern over the middle of the country that's going to feature a lot of storm systems flying through. These are going to bring a lot of moisture and increase risk of severe weather. And even for the eastern U.S., I think we're going to have a big ridge that builds. It could bring very warm temperatures. That's going to get everybody in that spring fever. But we'll talk about it all. We'll get as detailed as we can this far out, and then we'll round it off with today's weather. My name is Mitch. Good Thursday morning. Hope you guys are doing well. Subscribe if you haven't. Like the video if you like it. And if anybody has anything I can pray about or pray over, please put it in the comments below. Let's talk about some winter weather first. I'm going to start off with Sunday afternoon, March the 1st for the middle of the country, then quickly move into the eastern areas of the country. We have some moisture building. This is running into some cold air up top. And as we begin to move into Sunday night, into Monday morning, March 1st, into March 2nd, we get this area of heavy snow developing across areas in the Midwest, Iowa, northern Missouri, getting into Illinois. And this is the Euro from overnight, by the way. And then eventually we get into our Monday morning, March the 2nd. And we got this area of moderate to heavy snow moving across central, northern Illinois, Indiana, Indianapolis getting this. How far north will this trend? If it does, maybe it trends south. It all depends on this cold air press to the north and the ridge to the south. But this does bring a little bit of snow in Chicago. We'll watch for any kind of north trends for you guys. And eventually this moves into the eastern U.S. And that's where we will switch it to right here. And this is Monday morning starting off again. And then there's that storm system. This is our winter storm potential. And as we begin to move into Monday midday, it looks like the system kind of loses some steam somewhat. It might be getting sheared apart by this very strong high pressure to the north, but it's still delivering some winter weather across the Ohio Valley, Ohio itself, a little bit of a mixed bag of precipitation across southern areas of Indiana, northern areas of Kentucky. This could be a freezing rain sleet mix. We'll get super detailed with the details of this as we get a little bit closer. But this is bringing some snow into PA, even Pittsburgh, northern areas of West Virginia. And it actually gets pushed down. It kind of moves northwest to southeast, if you will, and moves into the mid-Atlantic and delivers some snow across the mid-Atlantic next Monday evening. And this is not a locked-in forecast, but it is kind of a light to moderate event as it begins to lose some of the intensity and the moisture. And but that cold air press allows it to get down into the mid-Atlantic and just delivers some light to moderate snow. Washington, D.C., Baltimore, northern VA, even all the way down to Richmond to the Delmarva Tidewater. And it actually gets some moderate snow pretty far south down into southern Maryland, southeast VA, and a little bit of freezing rain as far south as northern North Carolina as we're getting into our Tuesday morning. And then another area of moisture kind of bubbles up here. And I really think we begin to lose our cold air source as a ridge begins to flex during this time frame, which is going to introduce our next time frame of interest, where it's going to get very active over the middle of the country. But we get this ridge that flexes, and even though we get another push of moisture, our cold air is beginning to kind of surge back to the north. And I mean, it's still there enough to deliver a little bit of winter weather for New England Wednesday morning, but we have to watch that event to see if it trends any stronger. Now, what about the GFS with this system? It's a little bit further south, cold air push just a little bit further to the south, a little bit stronger. So we actually get a wintry mix across Kansas, some snow into Nebraska. And then this thing gets kind of beefed up here. It's very compact, and we get into Sunday night and Monday morning, the 1st into the 2nd of March. And we get a quick hitting winter weather event for Missouri. This is bringing some snow for Kansas City, some snow into St. Louis. And it brings just winter weather a little bit further south, but the system loses some steam here on at least the winter weather side of it. And it is colder than the Euro, brings some snow all the way down to southern Illinois, southern Indiana, northern Kentucky. But it's just not as juiced up to the northern side. Some rain to the south, and then the system begins to move into the east. And that's where we'll switch it to. And this is starting off Sunday night and a Monday morning, 1st into the 2nd. And we kind of get a longer system, more strung out, but a larger system. And this is Monday morning, for example. It's snowing as far west as Columbia, Missouri, and as far east as, almost into Richmond. So we got to have this long area of light to moderate snow breaking out across areas of the Midwest into the Ohio Valley into the Mid-Atlantic. And then this thing gets a little bit more juiced up here, and with a 1040 high, pumping down some really cold air, and it's got pretty good placement. For the GFS is thinking for next Monday, we're going to have a quick hitting snowstorm across West Virginia, northern areas of Kentucky, into Virginia, even bring some winter weather into northern North Carolina. And that cold air press continues to get positioned even better, and it bogs down the moisture and the cold air to the south. And we actually get some winter weather all the way down to northern North Carolina. It's crazy. It has kind of like a cold air oozing into moisture scenario. And by the time we get into Monday night and Tuesday morning, we have some winter weather trying to break out across areas of the Triad and Piedmont and foothills of North Carolina, mountains. Moisture tries to rebuild here as a ridge builds also, so we lose our cold air. And then as we're getting into Tuesday and Wednesday, it shows another juiced up scenario. But like I said, we don't have as much cold air with this as a ridge builds in. And delivers, though, an area of pretty heavy winter weather Tuesday night into Wednesday morning across the Northeast, and it actually switches the rain from the DC to the New York City to the Boston corridor, and then the pattern gets very warm after that. Now we will look at this is the Euro AI, Euro AI, and this is starting off Sunday midday. Here's some winter weather breaking out across the middle of the country, and it's kind of a middle ground between the Euro and the GFS, but it brings a little bit of winter weather for the southern areas of the Midwest and the Ohio Valley. But then, it turns into a more moderate event across the Mid-Atlantic. We got some snow right into here. And for example, this panel is for Tuesday. Yeah, this is Tuesday. And so it's a little bit, make sure I get this right. I'm sorry, this is for Monday evening, and delivers a swath of winter weather across the Mid-Atlantic. In fact, it literally targets the Mid-Atlantic here. And it actually tries to get a little bit of sleet, freezing rain as far south as northern North Carolina as we're getting into Monday night to Tuesday morning. And then here comes another system behind it, but it just doesn't look as impressive. So there's definitely a system that's pretty close to us that we need to watch out for. And here's the Euro as far as how much snowfall could occur. And this is just 10-1. And this is just one run, by the way. But I think it does a good idea gives us a good idea of showing us where the corridor of snow could be. But it delivers this swath of 2 to as much as 6 inches of snow across this region. Then it kind of has that secondary push of winter weather up here that you see in this weird gap. That's because there's a kind of a gap in precipitation, but even delivers a couple inches of snow, as far east as the Mid-Atlantic, but across the Midwest into the Ohio Valley, delivers a few to several inches of wet snow. Not as much for the middle of the country. I will show it here where it starts off, but does deliver a couple inches of snow here or there. GFS is actually not as aggressive as it was when we showed it to you yesterday morning, but it kind of weakens across this area, and then it gets stronger into the Mid-Atlantic and actually drops over a half a foot of snow in southern areas of VA, even northern areas of North Carolina, and has a lot of heavy snow in the southern areas of West Virginia, Southwest Virginia. But it basically delivers a quick hitting snowstorm across the Mid-Atlantic into, areas of Northwest North Carolina, and then the secondary push delivers several inches of wet snow in the Northeast. And then here's the middle of the country also. And it's definitely a bigger event, even delivers some snow for the Rockies. Definitely a bigger event. This might be another system. But anyways, we got a bigger event for areas of the middle of the country, several inches of snow in Kansas, into southern areas of Nebraska, and then right through the heart of Missouri. So it actually drops half a foot of snow just north of Springfield. So, this is not going to be even comparable to the blizzard we just dealt with, but it's something to watch. Now, if we look at the latest Euro AI, and I think this is actually the actual model run I showed you was the OOZ. This is the O6Z, so it might show something different. It looks a little bit further north. So it looks like there was a trend north with this. So it brings this swath of accumulating snow right to the upper Mid-Atlantic, kind of southern Northeast. It pretty much targets Indianapolis into Dayton, into Columbus, right into Pittsburgh, and then all of the northern and central areas of Maryland. Washington, D.C. gets a couple inches of snow off this, and the heaviest snow is just south of New York City. But it isn't like a huge event by any means, but certainly something to watch. There has been a trend. Let's look at the multi-run trend here on this really fast. Yeah, there's definitely a solid trend north on the Euro AI, which has taken North Carolina and most of Virginia out of it. So that is something to watch. But that's a pretty steady trend on the Euro AI. Now, there could be some freezing rain with this, and it's a pretty huge, broad signal, right? But anywhere that you live in pink, you just need to pay attention to the forecast in that darker pink. This is where the signal is higher for some freezing rain. Don't get too caught up in the numbers, just kind of where the pink is, I would say. Now, after this, all right, this is starting off Wednesday morning of next week, March the 4th, okay, 6 days from now. I think that we're going to get a pattern that's going to support multiple low pressures, and we're just going to show pivotal weather here flying across the middle of the country. Don't get too caught up in the specifics or one individual storm or anything like that. Just kind of follow the general theme and pattern here that we're going to get a lot of energy. You're going to see areas of green and not a whole lot of winter weather colors, but areas of green and yellow and orange fly around your screen. You know, this is getting into Thursday. This is getting into Thursday night. This is getting into next Friday. There's another low pressure cutting across the middle of the country. This is getting into next weekend. Here's another low pressure cutting across. Looks like it's bringing a lot of thunderstorms to the south. But this is 10 days out. And then we start to, man, this is slow. Come on, pivotal weather. Low for me. There's a low pressure right there. It looks pretty strong cutting into Canada. And if you notice, the general track here that all these are taking is like this, like that. Maybe like this. I'm going to talk about why the pattern supports a lot of cutters across the middle of the country here in a second. But as we move forward here, we start to get past 10 days from now. I mean, this is getting like into Monday, March the 9th. And the pattern continues just to support a lot of low pressures cutting across the middle of the country. And I mean, it does it through the entirety of the run. Eventually, some of this energy begins to get a little bit further east, like you can see this system right here, but this is very far out. But man, I mean, what an aggressive pattern. I'll back it up and kind of put it in quick motion for you. And I mean, low pressure after low pressure after low pressure, just a very active pattern. If you look at the GFS, it's the same thing starting off next Wednesday, and we'll get this in motion. Here, there's a low pressure right there. Next Friday, this is getting into the 7th. This is getting into the 8th. Another low pressure. This is getting into the 10th. This is the 11th. Look at. I mean, that's a big one right there. This is past 300 hours out, though. This is getting into the middle of the portion of March. On the colder side, this is a big blizzard. And I'm not going to speak a whole lot on winter weather in this time frame, but I would not forget about winter in this very active, warmer period that we're going to enter in March. I would watch out for the second half of March, and we'll get into that when we need to. I mean, there's so much to talk about out ahead of us. There's no point in getting lost in the details of that. But those are just two operational runs of the Euro and the GFS, and it shows just multiple low pressures cutting across the country. And, you know, this is all backed by the Climate Prediction Center. The risk of heavy precipitation, I think this will be mainly rain, between the 5th and 7th, which was in the time frame I just showed you with the operational run, you have a moderate risk of heavy precipitation. So I do think the flooding risk is going to increase in this area. And it always seems like Arkansas portion of March. On the colder side, this is a big blizzard. I'm not going to speak a whole lot on winter weather in this time frame, but I would not forget about winter in this very active, warmer period that we're going to enter in March. I would watch out for the second half of March, and we'll get into that when we need to. I mean, there's so much to talk about out ahead of us. There's no point in getting lost in the details of that. But those are just two operational runs of the Euro and the GFS, and it shows just multiple low pressures cutting across the country. And, you know, this is all backed by the Climate Prediction Center. The risk of heavy precipitation, I think this will be mainly rain, between the 5th and 7th, which was in the time frame I just showed you with the operational run, you have a moderate risk of heavy precipitation. So I do think the flooding risk is going to increase in this area. And it always seems like Arkansas is just the battleground state of this. It just seems like, I don't know, you guys have some of the craziest weather. And then the 5th through the 11th just has kind of a broader outlook and a broader time frame of a risk of heavier precipitation. So makes sense. And you go all the way out to about Monday morning. This is the Euro ensemble for total precipitation. Okay. This is going to blend in any kind of snow and rain and anything else, right? So, you know, it looks pretty active in the southeast, nothing crazy. Now, I want you to watch how this entire area right here begins to light up after you get deeper into next week. This is into the 3rd, the 4th, the 5th. Don't get so caught up in the totals, but just how the colors begin to show up here, which indicates, you know, we start to get into the reds and into the darker shades of red here and then browns. You know, there's the color key down here as far as inches of precipitation. But we get to day 10, we get into the 10th of March, we get into the 11th, and you can see just the pattern starts to get very active. That supports this very well. And we're going to just have a main avenue of precipitation right here in the middle to east central areas of the country of multiple inches of precipitation. So the pattern's going to get very active. And as far as severe weather chances, anytime that you see low pressures cutting across this way, okay, or just maybe across this way, you have to watch for a low-level moisture getting pulled north from the south. When we're looking at low-level moisture, we're looking at dew points, okay? And we're getting closer to March. That's when severe weather season really starts to get crazy for the deep south and Dixie and stuff like that. So I'm going to start off Wednesday, all right? And this is the Euro ensemble mean, the averaged out members here. We're already getting a signal for dew points 60 plus. When we start to get dew points over 60, that starts to really get into the threshold of dew points that support severe weather. Okay, so as we move forward, I'm going to kind of move through this as fast as I can here. We get into Thursday, you're going to just see that moisture hanging out to the south. I mean, we get into like next Friday, and we get a massive area that shows dew points in the 60s. And remember, this is blending together 51 members, so this isn't exactly the way it's going to play out. But look at this as a signal that moisture is going to be rising north due to the ejection of these low pressures and just the flow of the jet that's going to be in place, and just the flow, at the bottom edge of this jet, and these low pressures are going to be yanking in a southerly flow. So, we start to get into day 10 next weekend. Looks like you got a pretty broad moist sector. Looks like it could begin to move into the southeast too. So it actually can not only get very warm across the eastern and southeastern U.S., but it could get pretty muggy too. And the signal continues to stick with us. Down at the end of the run, it looks like the moisture gets suppressed again. But man, pretty big signal for a several day period of higher end moisture. And if you look at the Cape levels, and due to the response of higher dew points, your Cape levels are going to respond to be higher. But you kind of get this area of several hundred joules per kilogram in Cape that begins to spike up. Even get some areas down here where the mean smoothed out average is over 1,000 joules per kilogram in Cape. But that's a huge spiking in Cape, uptick in Cape in the pattern that's probably going to support some severe weather potential. So you can see it bubbling up there. Now, there is no day 4 onward outlook for severe weather. It does say potential too low until we get to day 7, where it says predictability too low. But it does mention the pattern shift. It says as we get into Wednesday and the Thursday, Ensemble Gaius remains in general agreement regarding the transition to an amplified western trough and central to eastern ridge. However, the timing and phasing of individual short waves, low pressures that we just showed you on the operational run, moving into the plains remains a source of forecast uncertainty. Of course it does. We're very far out. So any severe weather risk with this trough on Wednesday day 7 will be predicated on the evolution of moisture return on prior days. So, it does mention it. So when we look at the upper pattern, while we're going to get this transition in the pattern, this is going to be the pattern setup that kind of supports the potential for a winter storm across the Midwest into the Ohio Valley, into the Mid-Atlantic and Northeast. We got this kind of trough trying to dig down temporarily. You see this? And this is going to allow for the jet to kind of swing down here in some energy. And then this kind of piece of the polar vortex is going to swing over the Northeast and probably bring a nasty shot of cold air as we are getting into like early next week or something. But then after that, we move past the winter weather stuff. All the cold air kind of gets locked up into Canada. You're going to see the yellows, the oranges, even some reds pull up across the eastern U.S. This is the signal for a very strong and well-positioned ridge for everybody gets sensitive when you call it a torch, but for a well above average temperature pattern across the eastern U.S. When you have this tall spiking ridge and kind of the mean strongest area of the ridge is centered over in an area, you're going to get well above average temperatures. And as we're getting about a week from today, getting the next Thursday and Friday, that is a well-positioned ridge. It's spiking all the way up into eastern Canada. This is going to bring well above average temperatures. At the same time, we get this trough dropping down into the eastern U.S., this area in blue, and then we get a full connection of this trough. So we get into this time frame. And, kind of a funky look, honestly. It's a very extreme look one way or the other. And I'm just going to stop it here. This is getting into like late next weekend. So all of a sudden we get this pattern that supports the spiking ridge over areas of the Pacific, the spiking ridge, really tall spiking ridge over areas of the eastern U.S. So what's going to happen is energy is going to drop down here and then shoot up like this on the upper portion of the ridge. So that's why we're having these in the operational runs. Some of these low pressures that are just dramatically shooting like that is because we have this tall spiking ridge and the flow is just doing just like that. Okay. But man, we got to watch. I'm telling you, you got to watch deeper into March. Cold air source is still up here. And we just need to watch for a lot of cold air that can still drop into the country, even into March. And at the very end of the run, the pattern still looks very similar, but the ridge is starting to kind of lose its grip, but it's still over the eastern U.S. But no doubt we're going to enter a very well above average pattern across the south, the eastern U.S. The south, the pollen is about to get crazy in early March, so go on and get ready for it. And in response to that upper pattern, deep diving trough over the west, tall spiking ridge on each side, the jet is going to respond in that manner. So all of a sudden, in that same time frame, you can see exactly what happens here. You can see the flow is dropping down right here, and then it's dramatically spiking up just like that with a trough digging, ridge spiking, and that's exactly how our energy will travel. Okay, so that's going to pull in that moist air down from this area and yank it north. So hope that makes sense. And as far as temperatures, guys, we're going to get that blast of cold air probably Sunday into Monday across the Northeast. I mean, this could be record-breaking cold air, but it's going to be very fleeting. After that, we could hang on to some cold air, but then by the time we get into about this time next week, we already have well above average temperatures across the southern areas of the country, but then that tall spiking ridge will build over the east. This might end up moderating some and not being as warm as what's modeled, but this is the Euro ensemble. And in that kind of burgundy, whitish color, I mean, that's 15 to 25 degrees above average. So this is going to get you into the 80s in the south, no doubt about it. And this is really going to get the pollen going crazy. And I mean, it's a classic pattern where it cools down in the west, warms up in the middle to eastern areas of the country. So that tells us we got a trough out west, we got a ridge in the eastern half of the country, and therefore we're going to get a storm track. I mean, honestly, as a weather nerd myself, you can show me this map right here, and I can tell you what the storm track is going to be, because a trough is going to bring cold air, ridge is going to bring warm air, so you're probably going to have a battleground that's going to go right through here. So that's just the weather nerd in me, but we're going to watch this, and if you're a big fan of warm air and you're ready for a break in the cold, and I think we're going to get a big thaw coming up. So as far as today's weather, we got a system flying through. Wouldn't be surprised we're getting some wet snow in areas of the Ohio Valley and Midwest on the northern fringe of this moisture, but 95% of this system is rain, and we're getting a lot of it across areas of the east. We got some snow showers across the northeast, and we got this clipper moving through. It's going to bring a few inches of snow into the upper Midwest, the Great Lakes region. Outside of that, the west is pretty quiet. Watches, warnings, and advisories. It's honestly a pretty quiet day. There's nothing really worth mentioning a whole lot. I do want to mention this, though, and the light green, that's just a general risk of thunderstorms. And the dark green, that's a level 1 out of 5 risk. That's a marginal risk of severe weather. So some of these storms from Greenville, Greenwood over to Birmingham, and everybody in this green area could pack a little bit more of a punch, could reach severe limits. So be aware of that. As far as what the radar could look like today, for a lot of areas, just solid rain. But as we're getting into about lunchtime, 1, 2 p.m., we could get this area of kind of thunder showers, maybe some thunderstorms working its way through the Piedmont, the Carolinas, northern Georgia. And then as we get into this afternoon, I want to watch the southern flank of these storms, how basically ingredients can feed into these storms. And I want to watch these over here. They could produce some hail, maybe some gusty winds in areas of Mississippi and Alabama, and just a lot of heavy rain across the Carolinas and some storms into Georgia too. And these storms will just kind of drift north to south, and by the time we're waking up tomorrow morning, this stuff will begin to make it to the Gulf coastline and southern Georgia. But just watch out for those strong severe thunderstorms in central Alabama and Mississippi today. But in the Northeast, pretty quiet. I mean, I wouldn't be surprised you get a little bit of wet snow mixing in maybe sometime this morning across maybe the mid-Atlantic, but I mean, it's not going to be a big storyline at all. And then by the time we get into tomorrow, maybe some snow showers drifting into the Adirondacks, northern Vermont, New Hampshire, but not a big deal. South central U.S., nothing to really speak on. Some thunderstorms are possible in northern Louisiana, though. Maybe a rogue shower or storm in Arkansas, but outside of that, pretty quiet. North central U.S., area of snow is going to swing through the UP of Michigan, maybe northern fringe of Wisconsin, and get all the way into northern areas of lower Michigan this evening, and maybe some more moisture begins to swing into the north by tomorrow morning. But just a couple inches of snow is possible, just a dusting to an inch throughout the UP of Michigan, but a couple to a few inches of snow is possible across the eastern UP, northern areas of lower Michigan, as you can tell. So the west, it's a quiet day of weather. Nothing to really speak on, really at all. Most of the energy is remaining offshore. These are temperatures. It's warming up across the deep south, still cold across the northeast. And then this is out west, pretty warm. In fact, you might hit 100 degrees somewhere in southern Texas today. Pretty outrageous, but here we are. But that's all I got, guys. Thank y'all for tuning in. God bless all y'all. Appreciate the support. Devotions are still coming, guys. I'm doing a little bit something different. I'm going to be reading through my Bible again, starting from page 1 all the way to the end, Genesis, all the way to the end. So what I'm going to do really with my devotions, guys, is I'm just going to read a few pages a morning, and what I'm going to try to do is I'm going to find a verse that I'm going to find a verse as I'm reading, and then I'm going to kind of talk about it like I've been doing in the devotions at the end of the video. So I know I haven't had as many over the last several days, but I really want to challenge myself to read through the Bible. I wouldn't say that I've done it already, but I almost cleared through it a couple years ago, but I just want to clear through it again now that I'm spiritually a little bit more mature than I was a few years ago. There was times where I just kind of skimmed through some things, but I just want to read through everything again. So that's going to be a journey for me. Also want to ask for prayers for a sportsman's banquet tonight. It's going to be kind of a men's event at our church, and it is a massive opportunity for a lot of men to get saved and to give their life to Christ. It's if you're local to Lexington or just Columbia, it's at 5:30 tonight at Northside here in Lexington, South Carolina. People who are local to the area has probably heard about it, but reach out to me if you got any questions. I might can get you a quick free ticket or two. But anyways, I know that's kind of a long shot there, but pretty cool event. But anyways, guys, I also asking for prayers for my cousin's wife. Her name is Melissa. She found out she has I believe it's a very small spot on her lungs. On her liver, I believe it's her liver, and it could be a cancerous tumor. It might not be, but they're waiting on results back on that. They're very nervous, and she's young. She's only 35, and they got a little girl that's 3 years old, I believe, and I think she's 3. But just asking for prayers for healing for her and just for them. So that's all I got. Thank y'all for tuning in. God bless all y'all. Have a wonderful day. I'll talk to you again tomorrow morning.